Hey there, my name is Bharat, and I am a student at South Engineering College. I am currently pursuing my Bachelor of Engineering in the Computer Science division. So today you're gonna see about a small presentation on the topic mathematics behind linear regression. So what is linear regression? So linear regression is a machine learning algorithm based on supervision learning. It performs a regression task. Regression models are target prediction value based on independent values. It is mostly used for finding out the relationship between variables and forecasting. And before we get on to this linear regression, we must learn what is machine learning. So, machine learning is the concept that a computer program can learn and adapt to new data without human intervention. Machine learning is a field of artificial intelligence that gives computers built-in algorithms current regardless of changes in the worldwide economy. So we usually use machine learning to predict values and predict what other things we need. So in linear regression, this linear regression is analysis used to predict the value of a variable based on the value of another variable. So there are like two variables, which we namely call them as independent and dependent variables. The variable that you want to predict is called the dependent variable, and the variable that you are using to predict the other one is known as the independent. And these are the topics we're going to see today. So let's start up the above. Okay, so about linear regression. Linear regression is used to predict the relationship between two variables by applying a linear equation to the observed data. There are two types of variable. One variable is called the independent variable, and the other one is an dependent variable. Linear regression is commonly used for predictive analysis. For example, let's say that for farmer and for predicting the weather forecast, and it is mainly also used in speech recognition and facial recognition. So you need to put in data for the machine in order for it to learn, and then it will start using and process the data through the data that we just gave. And the next one, integration equation and formula. So we have you might have heard about the equation of the slope, which is y is equal to mx plus c, and this is that y is equal to a plus bx, and where the x right here is the dependent variable and it is plotted along the x-axis, and the y right here it is a dependent variable and it is plotted against the y-axis. Linear regression formula, by using linear regression formula we will find the value of a and b using the below formula. And as I said before, linear regression in machine learning is mainly used in real life. So let's go on with the next one. Real life examples. And in linear regression, we use them for forecasting, prediction, and for lots of other things. Just as I said, for recognition and security as well. In forecasting sales, organizations often use linear regression models to forecast future sales. This can be helpful for things like budgeting and planning. Algorithms such as Amazon item-to-item collaborative filtering are used to predict what customers will buy in future based on the past purchase history. If you get suggestions and recommendations to your Google feed, it is mainly due to machine learning. Next one, cash forecasting. Many businesses are using linear regression to forecast how much cash they will hand in the future. This is pretty much very useful in stock market and cryptocurrencies. You can use linear regression and machine learning to predict the prices of the downfall and upfall of the prices in stocks, and we can make addition with the help of that. And let's go on to the next one, performance metrics. So there are like four type of metrics in linear regression, mainly mean squared error, root mean squared error, absolute mean squared error, and mean absolute percentage error. So here we see the mean x squared error. The mean square error tells you how close the regression line, taking the distance from the points to the regression line and squaring them. We can see that MSE is equal to 1 by n sigma of yi minus y1 the whole square. And the next one is root mean square error. Now, as we all understood what MSE is, it is pretty much obvious that we are taking root situation will give us RMSE. And the next one, mean absolute error. The mean absolute error is the simplest regression error metric to understand. We'll calculate the residual for every data point, taking only the absolute value of each, so that negative and positive results do not cancel out. And the next one is mean absolute percentage error. It is kind of similar to mean absolute error, but the difference is that we take the percentage error and not the absolute value when we calculate it. And that's pretty much it about the formulas we use in linear regression. And before we conclude, I just want you to look at this. This is a beautiful quote given by Nick Bostrom. Machine intelligence is the last invention that humanity will ever need to make. Uh, this is something we need to think upon when we create a machine learning program or machine learning device. We usually create it so that like it can decrease our workload and increase our like free time. So when we start to use a lot of machine learning things, machine learning stuff like that, our workload will eventually like it will fall down, and it will make our lives easier. Thank you.